All right, I want to review problem 3-6. This is part of your homework, and we went over this in class, but I want to go over it again so I can have it posted in Blackboard for you to refer back to. So take a look at problem 3-6 in your book so you can follow along with the illustration and the values that are given to you. So the first thing is I can map out the joints, the pin joints that are shown in this mechanism. And if I connect each of these pin joints from one to the other with a straight line, it makes a nice, neat right triangle for me. Alright, so in the book I'm given two values. I'm given a value for y, which is the horizontal leg of my triangle. That's 275 millimeters. And I'm also given a value for the vertical leg of my triangle, x, which is 150 millimeters. So that's all the information I'm given. Problem 3-6 is asking me to solve for two things. First of all, it wants to solve for the angle beta, and it wants to solve for the value of s. S are two simple links that are joined together, and the way I have it drawn out here, those two links form the entire hypotenuse of my triangle. Therefore, I can represent the hypotenuse of my triangle as 2s, 2 times the value of s. Okay, so let's go ahead and solve for beta. What does beta equal? Well, let's think about this. We have a right triangle. We know the sine of angle beta is equal to the opposite over the hypotenuse. In other words, the sine of beta equals 150 over 2s. Now that's two variables and only one known, so we don't really have enough information to solve using sine. Cosine of beta is equal to adjacent over hypotenuse. So the cosine of beta would be equal to 275 over 2s. Again, that's two variables, only one known. We don't have enough information to solve. Now, the tangent of angle beta would be equal to the side opposite over the side adjacent. So we would set that up as the tangent angle of angle beta is equal to 150 over 275. So we now have two knowns and one variable, so we can solve for that. So I can say that angle beta is equal to the inverse tangent of the side opposite, which is 150, over the side adjacent, which is 275. Okay, so when I do the math here, I should get 28.6 degrees. So I've solved the first part of the problem. Angle beta is equal to 28.6 degrees. The problem goes on to ask to solve for s. We've got two identical links. Those two links form the hypotenuse of my triangle. So remember, I've denoted that as 2s. So we know that we have a right triangle with two known sides. We're missing the hypotenuse. So we know that a squared plus b squared equals c squared, Pythagorean. Okay, we could also rewrite that as the square root of a squared plus b squared equals c. Okay, we just took the exponent off of c. Therefore, we had to transfer that to the other side, adding the square root over the a squared plus b squared. So I'm going to write this as the square root of 150 squared plus 275 squared equals 2s. So that gives me 2s equals 313.249 millimeters. Okay, that's my hypotenuse. So remember, we're trying to solve for s. So I want to take this a step further. I want to divide both sides by 2. All right, because I'm trying to get rid of this 2. All right, I just want to narrow this down to s. So when I do that, I get 156 millimeters. All right, and I've just rounded out my decimal places. I'm just concerned with whole numbers. So I can leave that as 156 millimeters.